Law of cosines. We're still working with oblique triangles, and we'll still use our standard labeling technique. So we'll put angle alpha across from side A and angle beta across from side B, angle gamma across from side C, or you may see capital letters used for the three angles A, B, C. The law of cosines you can think of as basically a generalized version of the Pythagorean theorem. The Pythagorean theorem applies to right triangles. The law of cosines applies to any triangle. And you can take a look at the first version here. In fact, right at the front of it, you can see the Pythagorean theorem. C squared equals A squared plus B squared. If we had a right triangle and A and B were the legs and C was the hypotenuse, then that relationship would be true. Well, what we're saying now is that this relationship is true for any triangle as long as you include this adjustment. So even if we have any triangle and side C is just some random side of the triangle, there is a relationship between that side and the other two sides plus the included angle. What do I mean by included angle? Well, notice the other two sides are A and B. They show up here a couple of times. The other thing that shows up is angle gamma. Angle gamma is the included angle. It's the angle between side A and side B. As long as you include the adjustment at the end, this law, this formula, works for any triangle. By the way, let's say that I did have a right triangle. Let's say that gamma was a 90-degree angle. Well, cosine of 90 degrees, you might have to picture a unit circle, cosine of 90 degrees is 0, which means this entire term would wipe out and I would be left with the Pythagorean theorem, which is exactly what you would expect for a right triangle. If the angle isn't 90 degrees, then cosine of that angle will not be 0, and I'll have that little adjustment to my equation. The proof for the law of cosines is a little challenging and messy, and so I'll leave that to you to look up in the textbook if you are interested. We will concentrate on using the law of cosines. One final word here, there are two other versions of the law of cosines, and you can see them here. Each one focuses on a particular side of the triangle. So the second one focuses on side B. You can determine side B if you know the other two sides, A and C, and the included angle, beta, would be between sides A and C. And same thing here, this one focuses on side A, linking it to sides B, C, and angle alpha. In any given problem, you'll pick the version of the law of cosines that matches the information you are dealing with. The law of cosines is the final tool we need to solve any triangle. Thanks for watching.